Welcome to an episode on finite state machines. Finite state machines are the keys to logic. They are the keys to predicting the emergent behavior of systems. They are the keys to designing systems that are effective and avoid bugs. So, finite state machine is a very powerful way to create logic in software, in video games, and very importantly today, in AI agents. So let's start by defining what is a finite state machine. Well, it is a system that has a limited number of states or modes and all the transitions that can occur between those different modes, between those different states. So let's think about a traffic light. Traffic light can be in one of three states: red, yellow, or green. And green can only go to yellow, and yellow can only go to red, and then red can only go to green. That is the way we've set up this finite state machine to transition between its states or its modes. And we can also think about a video game and a player. A player in a video game is actually either walking, or they are running, or they are sleeping, or they are attacking, or they are defending. And as we design our video game, we're continuously understanding what the different states the player can be in so that certain functions can be enabled. So when a player is attacking, they have the ability to enact damage on another player. When a player is sleeping, no monsters can touch them. When a player is a particular level, which can be another state or another part of a state that a player is in, it can access a new part of the game world or gain access to a particular item. If the state of the player's money is at a particular level, it can purchase a particular skin or weapon or defense spell. So finite state machines are essential for us to understand the mechanics of a world and how certain variables allow us to do certain things. Now let's talk about finite state machines and AI agents. Let's think about a deep research AI agent. So a deep research AI agent can be idle. It can just be sitting on a cloud somewhere, ready to be operated in a container, in a scalable environment that can spin up multiple parallel agents if the scale goes up. So let's say it's in the listening state, right? So let's go from idle, let's call it listening. All right, we're in the listening state, and it's listening for a particular stock to go above a particular price, let's say $300. The stock goes up above $300, and then that causes a transition into state, from state to deep research. So it starts doing its deep research, and it goes out and it pulls information on the stock. And once it's pulled information on the stock from a web search, it can start to go into an analysis state. Once it does an analysis, it can go into the compilation state. And compilation state grabs information from different places, consolidates it into a nice response. Then it can go into judge state, judging what was produced. And after it's judged what it's produced, it can create an output. Or maybe the state, the transition, takes it back to the beginning because the judge said that it was not good enough. Or we get to the end, which is the end state, which is the inside produced state. So you can start to see all these different states and all these rules, all these conditions that need to occur so that the different states can be accessed via the transitions. A car, another example of finite state machine, is either stopped, it's accelerating, or it is in a cruising speed. And there are other states and more complexity because the music can be on, or the parking brake can be on, or it can be on neutral, or it can be in drive. You can start to see that each state has a set of variables that can change. And when those variables change, you can move between the different states. Those variables can act as the transition connections. So imagine a decision tree of possibilities that are only active, that are only activated via certain events in the environment. And so that's what a finite state machine is. And it really helps you predict the emergence of your system. It really helps you understand the different sequences that your video game character will go through and the different conditions under which things could break as you're designing. So you need to predict how all the different possible states your system could be in so that you can avoid bugs in the code or functionality that you don't want. And even think about a user interface, right? So for a user interface to move between states, different things need to occur. So let's say we start at a search. Okay, we have the ability to go, we type in a search, we press enter, then we move to a different state, which is actually the search results being presented on the screen. And maybe we click into the search result, and then we go into a different state where we're actually heading to a different portal, heading to a different link. And then there's this whole finite state machine of the different things you can do in, let's say you entered an application like Notion. And in Notion, you can move between the different states. You can go into your home screen, or you can go into a specific note, or you can go into AI mode, you can go into typing mode, and there's all these different states that we're moving through these transitions, which in this case are buttons. In the case of the deep research agent that we were talking about for the stock, it was a trigger from the outside world. So finite state machines are very important for predicting emergence and for understanding the full life cycle of how we are designing our systems or we are designing our agents, the different stages they will embark upon. So thank you. If you enjoyed this video, hit like, hit comment, hit subscribe, follow for more content on building extraordinary systems, on working on your mind, on working on your body, being a hero, being the best possible version of yourself. I really enjoyed doing this video, and your views, your likes, your comments, your shares help me a lot, and they help the world, because the smarter we are, the more knowledgeable we are, the better and more peaceful the planet is for everyone. So let's keep building, let's keep going, and I will see you on the next one.